Hello, everyone, and welcome back to another Engineering 101 episode. Hello, Thomas. How are you?
Fine, thanks.
So, Thomas, would you like a cup of tea?
Oh, yes, please.
There you go. What's happening?
Oh, just do it yourself.
Oh, it's hot. Why is it hot?
Oh, in this case, we have some heat transfer.
But the heat is here. Why is it like hot here?
Yeah, the heat is here,
Mm-hmm.
down on the downside here at the glass, at the
Mhm.
spoon,
Uh-huh.
and then the heat is moving up to the cooler place here in the spoon.
So it travels through the spoon?
Yeah. So
Okay.
in this case, we are talking about heat conduction. So this is a kind of heat transfer.
Okay, interesting. So, and every spoon, this happens in all the spoons, regardless of size, color, whatever, material,
This
everything?
is happening at each spoon,
Yeah.
but there are
Mm-hmm.
differences. So it depends always on the material.
Uh-huh.
So some spoons are getting hotter than other ones.
Okay.
It depends also on the size
Okay.
and the diameter.
So bigger, like the spoon we eat with gets hot slower than this one.
Yeah.
Okay.
Yeah.
Interesting.
So in this case, if you want to know more about heat conduction, you have a look at this machine here.
Okay.
So it's our WL 420 dealing with heat conduction. So in this case, we do have different probes like copper, brass, aluminium, steel, stainless steel.
Uh-huh.
And this material behaves different.
Okay.
So we take one specimen, one probe, and put it here between our heater on top, and we have our cooler down.
But how does that, like, how is that related to the spoon?
Yes, so in this case, our heater is here our water.
Uh-huh.
And in this case, we want to have excellent results. We
Yeah.
do not want to have an effect caused on the ambient temperature in the room. So in this case, we build up a heater and a cooler down, so there is no influence of the ambient temperature. Yeah. So in this case, we are heating up here. We measure the temperature here on top at my
So
probe.
it's like the same but flipped.
Yeah, you are right.
Okay.
Yeah.
Okay. So and then the heat is, this is like the hot water,
Yeah.
supposedly.
Hot
And
water
then
here.
this is the end of the spoon.
And here is the end of the spoon. Yeah.
Okay. Okay. Interesting. And then the heat goes from the hot water till the end of the spoon. So
Yeah.
the heat is traveling from the top to the bottom.
Yeah. You're right.
Uh-huh.
Yeah, as here,
Mhm.
here is the hot area of the spoon, and
Yeah.
then it's moving up to this point.
Okay. Okay. Interesting. So then the heat, so this one after a while would be, this area would be a bit warmer here
After a
because
while.
right now it's cold, yeah, but after
Yeah.
a while it becomes.
So if there is normally not a cooler here, then, and you are only heating up now, the heat is going through the material.
Yeah.
Yeah, but in this case, we are focused on
the
getting
heat
some
moves.
more information about our probe, about the behavior.
Okay, so how the heat is moving
True.
using this material.
Yeah.
Okay.
Yeah.
Are we gonna, this doesn't show the people anything, so they don't know how is the heat moving, like.
Okay, so in this case, we make this visible with our software. So you can see here different lines of the temperature. And at the end, by some calculations, we have this black curve here in the case.
Okay.
So this is the thermal coefficient of our material, and this line is more up or down depending on the material.
Itself. Okay.
Yeah, so it's going up with the same temperatures when I use
so
some
it's
copper.
Like, it's like the zigzag is like it goes hot and then cool down and then hot
Yeah,
and then
no,
cool
the
down.
zigzag is the indicator of a coefficient,
Yeah,
the heat transfer coefficient.
Okay. Interesting. Yeah. Okay, that's very nice.
Yeah.
And like, so this represents the material we have, and then if it's like a material that gets hot faster, then it will go up.
Yeah, okay. If I put another probe in here, for
If you
example,
put copper,
and I have the same temperature more or less,
Uh-huh.
then this black line will be here.
Ah, okay.
If I take, for example, stainless steel,
then it's gonna go down.
it's a little bit down.
Yeah, because stainless steel is like the hardest to transfer heat. That's why they use it in stoves, in the handles of the stoves and everything, so we don't get burned when we hold it.
Yes,
right?
of course.
Okay.
So imagine if you use one made of copper. So then you cannot handle it.
Yes, and then I'll
So,
burn
so
my
in
hands
this
so
case,
fast.
you will find always some isolation on
Yeah,
it.
yeah. There would be like this rubber thing that holds
Yeah,
it
this
from.
or plastic.
Yeah. Okay, so
around
it
there.
doesn't transfer to the arms and burn you when you're using it. Okay, that's very interesting. So technically, like right now, the heat is moving from the top to the bottom,
Yeah.
and this is similar to this but upside down.
Yeah.
Okay, so the heat is moving. So this is the hot water, and it's moving.
Yes, the probe is similar
Be careful
to the
the-
spoon.
Yeah.
So in this case, here is the hot side. Here on top is the cool side. So the spoon, as a probe, is mounted in
And like this.
like this.
Okay. Okay, that's very, very interesting. Thank you so much, Thomas.
Welcome.